Hello, my name is Hailey Farrow, and I'm here today with Leslie Stegeman. We're from CostQuest's Associates, and today we're going to talk about the role of the national fabric in federal programs such as BEAD, the Broadband Data Collection, and other federal programs. To give you an introduction into who CostQuest is, we're a broadband consulting firm made up of economic network modeling, valuation and appraisal, and data science experts. Our team specializes in network cost modeling, broadband planning, mapping, government advisory, network valuation, and then creating and gathering data solutions needed to effectively inform broadband initiatives. Over the past few years, CostQuest has worked with the FCC on various projects related to their broadband funding programs. Back in 2021, we were awarded the National Fabric contract for the FCC to license our National Fabric data to use in their programs. We also work with the NTIA to license this National Fabric and our cost data to use in their federal granting programs and other federal granting programs outside of the NTIA. We also work with state governments and ISPs to support their various broadband mapping, broadband deployment, and funding efforts. Today, Leslie and I are going to walk you through the history of broadband mapping. What was the problem? What was the solution that then led to the creation of the national broadband maps? We'll give you an overview of the fabric, how it's built, what goes into it, the different versions that are released over time. We're also going to talk about the role of the fabric broadband serviceable locations in the broadband data collection, BEAD, and other federal granting programs. Okay, so broadband mapping. What was the initial problem? Right before the broadband data collection was introduced, the previous broadband mapping and data collection effort was Form 477. ISPs were required to file biannually to the FCC their coverage data at the census block level. The issue, though, if one location was reported served, then all the locations in that census block were served. It was missing locations in those census blocks, and it created what was known as the one served, all served issue. To work towards a solution to solve kind of these errors was the broadband mapping pilot project. It was put on by US Telecom in partnership with CostQuest and providers in the states of Missouri and Virginia to test the concept of a more granular broadband mapping effort. Instead of mapping broadband coverage at the census block, it tested what it would look like to map coverage instead at the location level, and specifically the coordinates of a specific structure's rooftop. On the screen, you can see a sample from this broadband mapping pilot. The blue image on the left is what we call a claw image. This is an example of 10 census blocks that would have been reported as served under the previous Form 477 data collection effort. And during the pilot, it was found in these same census blocks were actually unserved locations. In that right-hand image, you can see how we identified all the locations in those census blocks. And with the volunteered coverage data from the internet service providers, it was uncovered that there was unserved locations in those areas. Overall, the broadband mapping pilot found that 38% of rural unserved locations were in census blocks that were marked served. The results from the pilot program helped inform Congress's legislation, the Broadband Data Act. This proof of concept was used by Congress to come up with a solution to these Form 477 issues and create a new data collection method that was more granular and gave a better picture of where broadband coverage is and not to better target funding resources. Congress passed this Broadband Data Act in 2020, and it outlined a new solution for the FCC to implement. It required providers to submit their coverage data biannually at the location level to the FCC. It ordered the FCC to create a common database of all locations that are or can receive mass market broadband service, and also outlined the need for the FCC to create a challenge process, giving the ability for the public and other parties to challenge both the locations and the coverage data in the National Broadband Map. So one of the results was the National Broadband Map. When it was first released, it was the first ever location level map of broadband coverage across the US. As you can see on the screen, this is an example of all the individual locations in this particular area. The green location points are CostQuest's fabric, and the FCC ties the provider's reported coverage data that's submitted in the broadband data collection to each of these locations to create their national broadband map. Now, when you click on a location, you can see the reported providers, the technology, and the advertised speeds available to each location. There's also options on the top right hand of the screen that gives the public the ability to challenge the data within this map. There's also a separate place in the broadband data collection system to submit bulk challenges. Another result is a national broadband funding map. This is also created by the FCC. On the map, it shows the progress of federal broadband granting programs. You can click on a program and see how much funding was awarded under that particular program, to how many locations, and the amount of grants that were awarded to those areas. These maps are a big step forward and mark significant process in mapping broadband coverage across the US, helping solve the previous Form 477 one served, all served issue, and helping uncover those locations that would have been marked unserved under the previous data collection method. To provide some scale, the Form 477 data collection consisted of roughly 8 million data records, and now with the broadband data collection method, it now consists of over 150 million records. This is a significant leap in the data capture to represent broadband coverage and helps uncover where those coverage gaps exist. So why did CostQuest take on developing the National Broadband Fabric? Right when this project to create a granular broadband map was initiated was also around the same time as the COVID pandemic. We were seeing that the pandemic highlighted huge coverage gaps as more things went online and those without adequate service or no access at all had to navigate remote education, remote work, and other activities that move online during this period. Post-pandemic, many of these activities stayed online and also demonstrated the barriers unserved areas faced in participating in these opportunities broadband internet enables. So we made it our mission to work to identify all the locations in the US to help close the digital divide and get reliable internet to everyone. We understand that identifying the locations where people live and work is important in order to equalize access to these digital opportunities. We also wanted to help provide precise data to help policymakers and the industry better target funding resources to the areas in most need to achieve the overall goal of providing reliable internet to everyone in the US. To help reduce funding waste by providing a national location database that acts as a foundation for all parties to make decisions from, adding precision and continuity to decision making from both the government to the industry sides of the table. So that's a quick overview of what initiated the need to create the fabric and the national broadband maps and what was CostQuest's mission behind it. And now I'm going to pass it off to Leslie to dive deeper into the technical aspects of the fabric data and how we went about creating the fabric location database to solve the initial broadband mapping challenges, as well as how we created the process to navigate the challenges of identifying the exact broadband serviceable locations that met the FCC's definitions and requirements.
So with the broadband mapping problem defined and the governmental policies in place, CostQuest now had to develop the solution of how we were going to answer this problem. And so in order to do that, we first needed to understand what a BSL was supposed to represent. And per the FCC, a BSL should represent a business or residential location in the United States at which fixed broadband internet access service is or can be installed. And so our problem that we defined to solve was how to determine which buildings on a parcel are a BSL. So with that goal in mind, we also had to be aware of the issues that we might face during our process. For example, one of those issues is secondary structures. Many parcels have multiple structures within them, but how do we identify the correct structure that would indeed need service versus a structure that would not need service? We also had to be aware of addressing. Addressing is a huge undertaking, and how are we going to develop a process to correctly identify the address with each given BSL? So with the goals and issues in mind, CostQuest developed a process that can be essentially boiled down into two main steps. Our first step is bringing in our data sources. So we have hundreds of data sources that we use in the processing of the fabric to inform our decision making. The main data sources that we use are building footprints, tax attributes, parcels, addresses, and then we also use road segments, US Census data, satellite imagery, any sort of data source that we think can provide value to our fabric, we bring in and use it within our models. So once all of those data sources have been brought in and we've processed the data, we then move on to step 2. And step 2 is where we train our models. CostQuest has written its own machine learning algorithms to identify BSLs, and so we have to train those models and then run them. And then once they have been run, we visually verify some of our data, which I can go into a little bit later on. If we take it a step further to look at this process, the first step is to overlay the parcel data. So we first look at the parcels and we join tax attribute data to those parcels. The parcels in the tax attribute have a common identifier field that can be used to link those two sources of data. It's not always a one-to-one match, so sometimes there are parcels that we cannot match back to the tax attribute data, and sometimes there's extra tax attribute data that we can't match to a parcel. Sometimes this is just due to differences within that identifying field that makes it difficult to join. But once we have them joined, we then can learn a lot about the area we're processing. We can understand if there are multiple structures within a parcel. We can understand if there's been improvement done to this parcel. We know the land use category of this parcel, which can be a good indicator as to whether that parcel may have a BSL. So just with those two pieces of information alone, you really start to build a picture of the area that you are processing. The next step of our process is to incorporate building footprint data. So a building footprint is essentially the polygon around a structure. So if you were to be looking at satellite imagery and you see the rooftop of a structure, a footprint is just basically drawing around that structure to capture where it is. So in this image, you can see the red checkered polygons. Those are considered footprint areas. So once we have this footprint data loaded, we have candidate locations for the fabric. It also becomes the real world location of a textual address. So if we think about addresses, they're simply text fields. And in a typical geocoding process, the address is taken and it's geocoded to the closest road segment. With having footprints, we get a better and more accurate location of the actual structure and what that address truly represents. The next step in this process is applying our logic. So we have processed all of our data sources, we've done any linking that needs to be linked, and then we can apply our location and structure logic. And so once this logic has been applied, we then have fabric, the broadband serviceable locations, which are circled in white in the image. So once the BSLs have been identified, we then send about 600 to 800,000 out to be visually verified. In our visually verified process, we send out these records to a team of people who go through each of these potential BSLs to confirm whether it is in fact a true BSL or not. The records that are being sent out are records that don't have a great confidence score, and so we want to get a few extra eyes on that location. At this point, we have sent out about 3.2 million records to be visually reviewed. Once we have those visually reviewed records back, we then do our last step of our process, which is assigning an address to each of those broadband serviceable locations. So once those steps have been completed, we now have what is considered the fabric, the national foundations of locations, which are used by federal agencies for a variety of reasons. So the FCC, as Hailey has mentioned, uses it to facilitate the broadband data collection. It also is what is informing their national broadband map and their national broadband funding map, but they're also using it for ACP and USF obligations. Federal broadband granting authorities are also using this data to help facilitate their granting programs. So the NTIA is using it for their BEAD program, and the USDA and Treasury are also using it for their granting programs as well. But the fabric is not a static data set. The fabric is updated every 6 months, and these changes from version to version come in a variety of manners. So the first way that the fabric is changing and improving from version to version is through the FCC challenge process. That challenge process can be applied to the fabric itself as well as the BDC coverage. So within the BDC coverage challenge, ISPs and states can challenge whether they think another provider actually does provide service to that location. In the FCC challenge program for the fabric, it allows ISPs and governmental agencies to challenge a location to say whether a location should not be considered a BSL but has been identified as one, or that we have missed identifying a structure as a BSL. Another source of change from version to version is through CostQuest's continuous improvements. So with each fabric version, we implement various improvement methods to gain better results with the next release. The biggest source of change is new construction. New construction is happening constantly throughout the US, and how do we go about capturing those changes in a timely manner? And lastly, the changes from version to version happen through ISP reported coverage. Have ISPs built out? Are they changing their reporting? So those are the 4 main ways that the fabric is changing from version to version. If we want to understand a few of the CostQuest implemented improvements, we can first start by looking at addresses. So in version 2, we added secondary addresses to capture all units within a building or location. So this will now capture every individual unit within an apartment building. We also, in version 3, implemented a new address assignment process to better assign those BSLs with an address. We've also implemented the idea of exclusion zones. So exclusion zones are essentially areas where we're saying that no BSL will be. For example, if we think of national parks, Mount Rainier National Park at the top of the mountain is not going to have a BSL. So we have drawn boundaries around these areas, and if a BSL in our processing is placed within those areas, we just delete them from the fabric. This has limited the number of false positives that we're seeing in the results. We're also consistently adding new sources of data. So in version 2, we added a data source to capture demolished homes in Detroit and a data set to better capture monuments and memorials within DC. In version 3, we added a new address data set to better identify those new construction areas. And in the most recent version, we utilized alternative population measures to increase the accuracy of identifying BSLs, especially those BSLs in rural areas. So we did that through using human geography data and light sourcing data. And with those sources, we were able to more accurately hone in on where population is in fact living. Our other sources of improvement are through some of our data sources. So with our parcels and our footprints, we're provided that data through a vendor. And with each fabric release, we get a new updated set of those data sources. But in addition to that, with parcels, we have identified a way to better identify road parcels. Road parcels sometimes can lead to the misinterpretation of structures, so we set up a parcel to identify them as road parcels, so we're limiting the false positives in those areas. With our footprint data, it again is refreshed with every version, but we also noticed some areas where there were gaps. And so to address these gaps, we have sourced some of our own satellite imagery, and we developed a deep learning process to help us identify those footprints ourselves. So this deep learning process essentially looks at satellite imagery and is classifying pixels to say whether that pixel belongs to a structure or not. And so with this method, within Alaska, we were able to identify an additional 316,000 footprints within 445 communities. We then implemented this same process within the territories where we were able to add about 63,000 footprints. We're now using this process in high growth areas. So again, just trying to capture those new construction areas faster. And so we can do this by using more up-to-date satellite imagery and our own deep learning footprint process. The last source of CostQuest improvements is through our models. After each fabric release, we take a look at our models to see where there may be gaps and where we think that the models can perform better. And so in the most recent version, we implemented some new logic to better identify a single location parcel versus a multi-location parcel. A single location parcel is like what it sounds. It will just have one BSL. However, there are also parcels that may have multiple structures on them that may need service. And so we need to be able to identify these parcels to be able to accurately identify the correct structures as a BSL. And so we've implemented some model improvements to better capture those differences. If we take a look at Washington, we can kind of see the areas where we have spent time with improvement efforts to get more eyes on some of the output. So the pink are tribal areas, the brown are large parcels, and the green are visually verified areas. So those green areas have already been sent out to our team to be reviewed manually. The pink and the brown polygons are areas that we've also focused a manual effort to review because we know that sometimes due to the large nature of the parcels in those areas, the model does not perform as we would want. So we've spent a little bit more time reviewing those areas to make sure that the results are exactly what we want them to be. Like I said before, new construction is the biggest source of change from version to version. So the next series of slides will go through the changes from version to version, where they're coming from, and how you're seeing them. But it should be noted that the imagery behind the slides is imagery that you would see if you were to open a map today. It's not reflective of the imagery you would have seen at the time that we were processing these areas. So in version 1, in the middle of the map, you can see one large parcel. With version 2, we've seen that update to our parcel data. And so what was one large parcel has now become multiple smaller parcels. Similarly, in version 3, we again saw that update of parcel data, and what once was 4 large parcels at the bottom of the screen have been subdivided again. With version 4, we've also seen that update to footprint data. And so the footprints and with the parcel updates, we're now seeing that construction and build out have been happening on these parcels and that there are BSLs on these parcels now. But if we take a look at the left-hand side of the map, in that last row that has BSLs turned on, you'll notice a few that are being turned on without a footprint. And that is a result of our tax attribute data. So something within that tax attribute data is also cluing us into the fact that construction has occurred on this parcel and that there is now a building there that needs to have service. So with version 5, again, we saw that update to our footprint data, the tax attribute data, the parcel data, and with all of those updates, we're now able to capture all of the build out that has occurred in these areas. So with all of those various sources of improvement from version to version, we have seen a 40% decrease in our false positives from version 1 to version 5. So we are better able to eliminate those areas that we were in version 1 incorrectly identifying as a BSL. We've also reduced false negatives by 31% from version 1 to version 5. At this point in version 5, we are able to correctly identify a parcel with a BSL 99.5% of the time. And we're able to correctly identify the correct structure on that parcel with an accuracy of 98.8%. The last source of change from version to version comes through the BDC coverage map. So in version 2, there were about 114.5 million locations throughout the United States. In version 4, that BSL count went to about 115.7 million. With the ISP reported coverage in version 2, there was 8.5 million unserved, and in version 4, there was 6 million unserved. If we look at Washington, in version 2 it was 2.5 million total locations, and in version 4 it was 2.6 total BSLs. And that unserved count went from 236 unserved to 200,000 unserved. And so with this, you can see how those coverage reporting is changing from version to version. Version 2 is what the NTIA used in their allocation of BEAD. So they used the unserved and underserved counts from version 2 to allocate that funding. These are some maps to illustrate those counts we were just reviewing. So it is a zoomed in version of an area in Washington. And if we look at this little island in the middle of the map, you'll see that it's almost entirely unserved. As we move to version 3, it becomes a little bit better, a little bit more served, but not completely served. And in version 4, it stays pretty steady. If we take a look at the upper left-hand corner of the map, in version 2, you'll notice there's pockets of served, but predominantly it's unserved. As we move to version 3, those pockets of served grows and the unserved lessens. But in version 4, whether it be due to challenges to the BDC data or changes in ISP reported coverage, we see what was once being considered served in version 3 has gone back to being considered unserved. So those are the main ways that those changes from version to version are happening. I'm now going to hand it back over to Hailey so she can walk through how the fabric is used in the BDC and the FCC programs.
Okay, so now I'm going to talk about the role of the fabric broadband serviceable locations in the broadband data collection and FCC programs. So there are two contracts for the national fabric data. One is with the FCC and one is with the NTIA. The FCC contract came first. This was outlined in the Broadband Data Act for the FCC to create this national fabric database. So the FCC contract outlined the need for the broadband serviceable location fabric, and it came with exclusive uses for that data. So these are all the types of licenses that are available underneath that FCC contract to use the fabric data in their programs. I'm going to focus specifically on the Tier 2 license underneath the FCC contract. This license is for the ISPs, state, local, and tribal entities. The permitted uses of the fabric data under this license are to correct, create, challenge, and submit broadband availability data to the FCC in the broadband data collection, fulfill reporting and/or compliance requirements associated with the Affordable Connectivity Program, fulfill reporting and/or compliance requirements in regard to the Universal Service Fund and USAC's high-cost Universal Broadband Hub program, reviewing, implementing, and/or revising deployment obligations for the Rural Digital Opportunity Fund and other FCC programs outlined in the license agreement. It does not allow the use of the data for state and federal granting programs or commercial uses outside participation in FCC programs. Be cognizant of those permitted uses underneath the license agreement. CostQuest conducts ongoing reviews and audits for proper usage of the data. So now I'm going to go over the role of the fabric broadband serviceable locations in BEAD and other granting programs. The second contract for the fabric is with the NTIA. It covers the use of the national fabric and CostQuest's national fiber and fixed wireless cost model data for the NTIA, pass-through entities, other federal broadband granting authorities, and their participants to use the data in these granting programs. Below are the licenses that are available underneath this contract. Today, I'm going to focus on the Tier C license and Tier D. Tier C is for pass-through entities. In the case of BEAD, it is the states and territories that are the pass-through entities administering the BEAD federal broadband granting program. So this license allows any pass-through entity administering a federal broadband granting program to use the data. The permitted uses of the fabric data underneath this Tier C license gives pass-through entities the rights to use the fabric and cost data in their federal broadband grant program, but it does not allow the use of the data for commercial uses outside the participation in those programs. For the Tier D license, it's for ISPs participating in federal broadband granting programs. The license rights cover approved participants and subgrantees for those programs. The permitted use of the fabric data underneath this license covers participating, reporting, and challenging use cases associated with the federal broadband granting program and the eligible locations. This includes NTIA's BEAD program. Again, similar to the FCC license, it does not allow use of the data for commercial uses outside the participation in the federal granting program. So again, be really cognizant of the permitted uses outlined in the license agreement, and there will be reviews and audits to ensure proper usage. Here are other federal broadband granting authorities that have access to the national fabric and cost data, as well as their participants to use the national fabric data in the grant program. This includes agencies such as the Department of Agriculture, Department of Commerce, Department of Education, Department of Treasury, and so on. So now I'm going to give an example of how the fabric broadband serviceable locations will be used specifically in the BEAD program. So in the BEAD program, each state is required to conduct a state challenge process based on the fabric broadband serviceable locations and the broadband data collection coverage data submitted by providers. Each state or territory takes the current version of the fabric and BDC data available at that time to run their state challenge process to determine which locations are eligible to receive BEAD funding. They also weed out locations that are covered under existing granting programs to reduce the amount of overlap in funding. The result of this process is the eligible locations available for BEAD. The state or territory submits these eligible locations to the NTIA to approve, and the outcome is the eligible broadband serviceable locations and community anchor institutions that can receive BEAD funding. Next, the state and territory will then develop those broadband serviceable locations that are eligible for BEAD into project areas for bidding. One thing to note is that there's going to be different versions of the fabric and BDC data in BEAD. It really depends on when the state ran their state challenge process, which version of the data was available at that point in time. So here's an overview of the different versions of the BDC data and fabric. Fabric version 2, which was released in January 2023, and broadband data collection version 2 was released in May 2023. Version 3 of the fabric was released in June 2023, and the BDC version 3 was released in November of 2023. Fabric version 4 was released in January 2024. BDC version 4 was released in May of 2024. Fabric version 5 was released in June of 2024, and the broadband data collection version 5 is expected to be released in November later this year of 2024. So again, just really note which version of the fabric your state that you're applying in ran their challenge process. Another thing to note is what is called data upversioning. So a state or territory may start its challenge effort with one version of the fabric and broadband data collection data from the National Broadband Map and choose to upversion before the grant effort begins. An example would be Louisiana used the broadband data collection and fabric version 2 in its challenge efforts, and then chose to upversion to broadband data collection and fabric version 3 in its filing of the eligible locations to NTIA. So really make sure that you're understanding which version of the fabric and BDC data that your state is using to administer the BEAD program. Once the state and territory has those eligible broadband serviceable locations for BEAD, they then aggregate them into state project areas. A state project area represents geographic aggregations or location level areas of unserved and underserved locations available for BEAD funding. Each state has outlined their specific state project area types. Some of the state project area types are what are called Hex 9, which is essentially a hexagonal geographic shape that covers roughly a few city blocks within it. There's going to be census tracts, census block groups, and census blocks. Location-based project areas, which are essentially custom geographies of locations that are defined by the applicant. Objective-driven clustering, using specific parameters to define how locations are clustered. City, county, and school district boundaries. Just to give you an example of how these project areas are defined by state, an example would be in Louisiana. They conducted their challenge process and created what they call sub-project areas of their eligible locations. A sub-project area is a set of BEAD-eligible broadband serviceable locations that include unserved, underserved, and community anchor institutions that function for an application unit for their Gumbo 2.0 grant applications. They then posted the reference funding available for each project area and how many eligible locations were within each sub-project area. On the right, you can see an example of the map Louisiana posted of their sub-project areas. To zoom in a little further, this is an example of a sub-project area. This highlighted SPA cluster has roughly 377 locations within it. Another example of how state project areas are being defined, project area type, is county boundaries, with projects within these boundaries clustered in census blocks with roughly 1,000 broadband serviceable locations within each. Washington is in a draft project area mode, so these project areas are not final, but this example is to give you an idea of a different project area type and how a state is aggregating those eligible BEAD locations. To zoom into the map a little further, here's an example of one of those draft project areas in Washington. On the right-hand side, that green project area, when you hover over that project area, you can see the county that it resides in. The number indicates what project area in that county that project area belongs to. It gives you the total amount of unserved and underserved broadband serviceable locations in that entire project area. It gives you the census block identification number, and you can also hover over each of the census blocks within that project area and see the total unserved and underserved locations within those. Again, these final numbers are subject to change in these project area types. So this is just to give an example of how this might look in the state of Washington. And again, other states are going to be different. Other states may have school districts as their project area boundaries or counties. So really look out for the differences, especially if you're going to be applying for BEAD funding in different states. Key takeaways from today is really understand the fabric broadband serviceable locations and broadband data collection landscape. Really understand the differences in the types of licensing, know which license you have, and the allowable uses underneath that license. There are commercial licenses available for CostQuest's fabric, cost, and other data layers to use in internal business operations. Also understand the different fabric and BDC versions, and also the nuances between up-versioning, especially in the BEAD program. Understand that you might use a different version of the fabric depending on what federal program you're working within. An example of this would be if you're filing your broadband data collection data, you're going to want to use the most recent version of the fabric that's provided to you for that specific filing. But if you are applying for BEAD funding, you may be using a particular version of the fabric defined by the state to apply and report progress on that specific area. So again, just really understand the differences in the Fabric versions and what version of the Fabric you should use for each program. We really hope that today provided you some helpful information. If you have any questions, feel free to email us at info@costquest.com. Thank you for watching. Have a great day.